This is a presentation on factoring a difference of squares by Mathematically Marcia. If you watched my video on multiplying sums and differences, you saw that when we took A plus B and multiplied it by A minus B, the middle terms always canceled out, and we got what's called a difference of squares, or A squared minus B squared. For this video, we're going to go the other way. We're going to take the difference of squares and we're going to factor it to find the sum and difference. So now A squared minus B squared, we're going to factor and we'll get A plus B, A minus B. Now it could also be A minus B, A plus B. The order you put it in doesn't matter. But multiply sum and difference, you get difference of squares. Factor a difference of squares, you will get a sum and difference. So let's look at a few examples. Here we have x squared minus 16. We know it's a difference of squares because both of these are perfect squares and it's a subtraction in the middle. So to find A, we take the square root of this first term and we get x. And to find B, we take the square root of the last term without the subtraction sign and we get 4. So now we just plug it in. You have x plus 4 and x minus 4. Now keep in mind, you could put the minus first. That order, which one comes first, is not important. Okay, let's look at a second example. Again, both terms are perfect squares with the subtraction sign in the middle. So we take the square root of this one, and that gives me A, which would be 3x. Square root of the last term means B equals 7. So we have 3x plus 7, and we have 3x minus 7. Okay, let's factor this next one. Take the square root of the first term to give us A. So square root of 4x squared would be 2x. Take the square root of this term to give us B, and that would be 5y. Again, remember there has to be a subtraction sign in the middle in order for it to be a difference of squares. So now we take and we plug in A and B. So 2x plus 5y and 2x minus 5y. Okay, this does not look like a difference of squares because 18 and 32 are not perfect squares. However, we do have a common factor. We can divide both of them by 2. So let's take that common factor out. That gives me 9x squared minus 16y squared. Now we do have a difference of squares. 9x squared and 16y squared are both perfect squares. So the square root of 9x squared would be 3x, and the square root of 16y squared would be 4y. Now the 2 that was a common factor becomes a permanent fixture. We bring that right down into our answer. And then we do our pattern, a plus b, a minus b. So 3x plus 4y and 3x minus 4y. Okay, we have another one here that doesn't really look like it is a difference of squares, but they have a lot in common here. We know they can both be divided by 3. They both have at least one x, at least two y's, and a z. So we can divide them both by 3x y squared z. And then let's put our common factor up front also. So that gives me 3x y squared z, and then 4x squared minus 25y squared. Now I do have two perfect squares. Square root of 4x squared would be 2x. Square root of 25y squared is 5y. So again, our common factor is like a permanent fixture. We don't really do anything else with it, but it remains in our answer. And we do our a plus b, a minus b pattern. So 2x plus 5y and 2x minus 5y. And that is our answer. If you'd like to see more videos like this, you can subscribe to my channel below and share with us any comments you have, questions, or future topics you'd like to see. Thank you for watching.